Hey everyone, thanks for joining. We're gonna give it about a minute for folks to be able to join. While we're waiting, just a bit of housekeeping. Please feel free to throw comments in if you have any questions. I'll probably answer them as I go if possible. If not, I'll save a few minutes at the end and we can hopefully go through some of them. If I can't get to them on this webinar, I'll make a note for folks that want to talk more. I can definitely get you some answers afterwards. So, like I said, we'll give about a minute and then we'll go ahead and get started. All right. So again, thanks for joining our webinar today. The focus for today, if you join the last one, we're going to be focusing a lot more on the monitoring aspect uh, of of managing models in productions. So last time we talked a little bit more about data quality and data drift. This time we'll be talking about performance, and performance doesn't just mean the performance of a model itself, but really the performance of a whole system. So let's dive in and we'll go into our agenda. So what we're going to talk about today. So we're going to start with, what does ML monitoring mean? What are the three pillars of monitoring? And then we'll talk about those three pillars for different types of applications. We'll also talk about what you should monitor. So for those three pillars, what makes sense? What are the scenarios that we should be looking for? And then lastly, how can we use WhyLabs to help? So again, if you have any questions, any thoughts, please feel free to throw them into chat. As we're going along too, would love to know, what you're curious about, especially when it relates to monitoring. What's most important for you? What are the types of problems you're solving? Also, if you have any models in production, like how many models in production do you have? Would love to encourage folks to to put their thoughts on what's most important to them and also what kind of problems they're solving. So a bit about me. My name is Andre Elizondo. I'm a principal solutions architect here with WhyLabs. I'm based out of Seattle, Washington, and I love coffee. So that's a little bit about me. I tend to take it in some form of espresso form, so it tends to be an americano. I would love to know what kind of coffee you like. If you like coffee at all, some people like tea. That's okay. Uh, so that's a little bit about me. And like I said, I'm in Seattle. Would love to know where folks that are chiming in, where you're coming from. What area of the world are you watching this stream from today? All right. So what is ML monitoring? We're going to spend a minute or two talking about this because this tends to be a really important topic. Once you focus on uh, getting the right data, training your model, getting the right model, and deploying it into production, it really becomes important to ensure that your model is continually doing what you expected it to do. And that tends to be a much harder problem, especially as your model becomes more important. So when you think about what are the core pillars of monitoring an ML system, it tends to come down to model inputs. So looking at data drift, identifying data quality problems, identifying schema changes. This is incredibly important, right? Because unlike when you're training the model, you're kind of handling everything. You might be working in a notebook, doing a lot of things ad hoc. Typically, when your model's in production, you don't have as much control over exactly what data is fed into it. And that might be different for everyone. Maybe you are doing a little bit more of this ad hoc. Maybe you're running your batches by hand. But for the majority of people, especially if you're doing any kind of automated batching or you're doing streaming or real time, this becomes an incredibly challenging problem, just ensuring that the right data is actually feeding into your model. The other thing is model outputs. So not just what's feeding into your model, that's incredibly important, but also what is your model actually doing? For instance, if you're doing something like fraud detection or some kind of binary classification, if you see that all of a sudden your model is doing something insanely different than it was either when you trained it or over the last week or over the last month, you want to be able to have that level of insight, even if that's something that's expected. It might be, a scenario where you need that level of auditability and when that change happened. And if it's unexpected, maybe that'll prompt you to do something like retrain your model, or go make a change in your data if there's a problem with your data transformation that's impacting your outputs. Also, in the concept or in the topic of outputs, not just what your model is creating, but folks tend to have things like business KPIs, additional metrics, things that aren't just direct outputs of the model that they want to be able to track over time. And that kind of bleeds into the last pillar here, which is model performance. So when most people think of model performance, they tend to think of this last column here. So looking at things like accuracy, precision recall, if you're working with a regression model, classification model, a ranking model, they're going to have different ways that you measure performance. And also those business KPIs, like I mentioned before, there might be a certain percentile that you're calculating, a certain count that you're calculating, that you're reporting back to the business on how your model is actually generating ROI. And so typically that becomes a critical factor in measuring performance. And like we tend to say when it comes to ensuring you have visibility into all these three pillars is, it tends to be that bad data happens to good models. So even with the best intentions, we want to make sure that we have the right level of monitoring and observability here. So a few different scenarios here. Like I said, this might look different depending on the type of use case that you're running. If you're working with text, there's a number of different things that you might want to be able to extract from your text. Anything from the amount of n-grams, topics, character statistics, or any specific metadata about the text. Another common one is measuring the embeddings, the transformation step when you're actually creating those embeddings and the distance in between different clusters. And things like output, so what's actually being produced by your model. You can capture a number of different things here as far as what was the output length, what was the confidence, any kind of categorical fields. And then performance, tends to be the kind of model that you're actually using with that text-based application. Audio is similar story where depending on what type of application you're processing audio for, you might be wanting to extract spectrogram features if you're working with spectrograms, any kind of metadata, so any kind of like QuickTime or exif file metadata tends to be really important to understand over time, as well as things like unique outputs, so the number of words detected, number of speakers. There's a lot of different things that we can derive or extract from your audio models to help you to understand maybe why a particular behavior is happening or why a particular behavior has changed. And the last one, images. We tend to see things like image features extracted, so brightness, luminosity, maybe entropy, any kind of metadata similar as before, as well as a number of different types of outputs. So things like bounding boxes, categorical output properties, and then potentially some custom performance metrics there, depending on how you're measuring its success. So let's look at a few different scenarios here. I mentioned that those three pillars tend to be common, even if you're not just working with tabular data. If you're working with really any kind of data, it's important to ensure that, one, you have quality data feeding into your model. This can help you to identify things like external changes, so any kind of bad data that's gotten into your pipeline, data source has changed. If you're working with computer vision, maybe your camera is pointing in the wrong direction, or all of a sudden a change has happened that's impacted the quality of your data, or the schema has changed, or really any kind of pipeline bugs that might impact the quality data that's actually supposed to be feeding into your model. Drift is another one that we tend to see as a common way to monitor your ML systems. Again, talking about those inputs, you want to make sure that not only is your model getting high quality input data into it, depending on the type of use case that you're putting your model to work for, but you want to make sure that data is the closest thing to what your model actually understands, right? That could have a number of different impacts across a number of different factors. So Maybe your model hasn't been trained in a number of months or weeks or years. You could be impacted by things like changes in seasonality, changes in new categories, or just changes in kind of external conditions that you can't really control. And what that tends to do is impact the model itself. So when you're looking at external changes, this is something that can change the inputted data. It might be something that can introduce a drift. And you tend to not only see the drift in the inputs, but also something like a concept drift, where you're actually seeing that maybe your model isn't producing the kinds of results that you expected. Maybe if you're doing like a fraud model, maybe you're denying a lot more people than initially you saw as a distribution a month ago, a week ago, or anything like that. Or maybe you're approving a lot more people that you didn't expect. Some scenarios that we see, right, are things like changes in the housing market, COVID-19. There's a lot of different external factors that can play in here that can really paint a picture of why it's incredibly important to understand a drift in concept and understand a drift in what your model is outputting. So a couple things to highlight here. There's different ways to look at this problem. So when we're looking at those three pillars, what should you monitor? What are the critical things to ensure that you have coverage for? We can look at it from a few different angles. So one is looking at it as you want to be able to understand your ML application. So you want to understand your features, your model endpoints, your predictions, your ground truth, and any kind of KPIs that you might also be tracking as well. You want to be able to understand when something changes at any point there. So when you think about like, where do I start? If you're trying to think about what's a monitoring strategy that I can implement either for myself, my team, my company, we tend to see as a starting point to really just focus on monitoring your inputs and monitoring your performance if possible. Understanding that you have high quality data feeding into your model tends to be a really good first step, and that tends to be where we recommend people start. If you don't have a good sense of what data is being fed into your model, is it close to what you trained it on? Is it close to the same time last week, last month? If you don't have that level of visibility, it's really hard to start measuring some of the more downstream, like those trailing indicators of things like, your accuracy went down or a KPI went down if you don't have visibility into how your data is performing. And then the other thing is, like I mentioned, looking at it from a second angle here is understanding when changes happen. So for instance, if your model is trained on a certain data set at a particular point in time, you want to be able to understand how your data is changing, how you're seeing things like training serving skews, if you are seeing them, how you respond to them, how you maybe trigger a retrain, how you can maybe fall back if you see that your model isn't performing very well. Like understanding how these changes happen, and not just over time, but over specific periods, it becomes a great next step to really understand how your systems are performing. So doing things like ensuring that you're capturing a profile of your data set, or really understanding your data set at the point of train or at critical stages when you want to understand how things compared today to those particular points in time. That tends to be a really good next step to really just start tracking how your model reacts to change and how things change over time. And then lastly, the final stage of really understanding and analyzing change is the analyzing part. So being able to, once you have visibility into your model inputs and performance, once you have an understanding of what your model is trained on, you have visibility into the data over time, it becomes possible to be able to understand things like distribution drifts, or when you see a bug in data quality, when you see a degradation, and then ultimately what your customers are going to be impacted by. So this tends to be where you get to after you have those first two things implemented. So you can actually understand, if your data set is seeing a sudden shift in distribution, if your models are seeing a sudden drop in accuracy or F1 or any kind of measurement that you're using there. And it tends to be a good way to kind of take a trailing indicator, look at your leading indicators, and form an opinion on what you need to do to resolve that. So let's talk a little bit about WhyLabs. So we talked about what you should be monitoring, why you should be monitoring that, and also what are the different kind of phases of monitoring, or what are the different ways that you can look at the problem. Let's talk about WhyLabs. If you're not familiar with the platform, we come at it with kind of a two-pronged approach here. One is we have WhyLogs, which is our open source data logging library for being able to help you understand your data. We can profile massive amounts of data, capture what's important and exclude the raw data, and actually create a profile of what your data looks like at any point in time. We could do that at the point of training. We could do that continually for a lot of different types of workflows, streaming, batching, really anything that you want to be able to capture a point in time on what your data look like. We can use WhyLogs to create that consistent profile. And then what we do in WhyLabs, which is the platform, is we have a SaaS where you can actually aggregate those profiles over time, look for anomalies, identify any kind of outliers. You can look for really complex trends or very simple trends, right? Hey, I expect my accuracy to be above a certain threshold, or hey, I expect my drift to be under this certain threshold, or I expect maybe this distributional statistic to be kind of within this bound over a very complex thing, maybe like seasonality or something even more complex than that. Really just helping you to understand your data over time, and then allow you to react to change. So for instance, if you do see a certain amount of drift, or you do see a particular degradation, maybe you want to either fall back to a previous model version, maybe you want to trigger a retrain of your model, maybe you just want to notify the right people through maybe a webhook notification, Slack notification, trigger a pager duty if it's mission critical, but really just let the right people know when something has happened to your model, your data pipeline, or anything that you're monitoring in the platform. So we'll go ahead and take a look and see, really how we can put WhyLabs to work here and understand our data, understand our data set. And I'll walk you through a couple of examples. I'm going to check chat. I don't see any questions just yet. If you do have any questions, please feel free to throw them in. All right. So one particular example I'm going to look at here, I'm looking at a text-based classification model. And to do a little bit of setup, this is actually a tutorial you can run through yourself. I'll put a link in the chat. What we can do here is we're capturing a reference point of not only the text, the tokens, but also our embeddings. And we're going to be looking at a few different factors on how we can identify drift in our model, how we can identify a quality problem, how we can identify a performance change. And it's as simple as just capturing the right information through something like a y.log. So WhyLabs is really easy to instrument here. Like I said, we can just capture, for instance, a particular point in time when I really care about understanding what my data looked like, right? So we'll dive into this. We're not going to go super in depth here, but I'll point out a few different kind of unique things. The one thing I did want to point out here is that I'm using segmentation to be able to understand the different groups of performance cohorts. So when I'm looking at performance here, I'm going to drill down into certain prediction targets. So I can look for, what happens when I predicted a particular article to fall under this label. And then I'm also capturing, like I said, the information about the tokenizers, information about the raw inputs, as well as information about the outputs here. And so we'll go ahead and jump into the platform. And what I did here is I created an expected performance drop for the sake of a demo here. So to start off, I can see that WhyLabs immediately notifies me on the summary page on my main page here that something's really gone wrong. I see that there's a 58% drop in the accuracy of my model. I see that it's 27%, which maybe on its own is maybe if that happened immediately, that's probably something that's incredibly important for you to be notified of. If it was a slow degradation, you also probably would want to understand how this change happened over time. So we'll drill in here. We'll start here, and we'll see that, for instance, here I can see that even though the volume didn't change drastically, it's kind of within the same trend line that I see. I can see that an accuracy drop has been happening kind of slowly over time here. And like I said, this is expected in this scenario here. I actually introduced a particular translation problem, which I'll talk about in a moment here. But I can see what the trailing indicator that I'm looking at here, which is the accuracy ultimately went down. The false positive rate went up. The F-score went down. So I can see there's a number of different indicators here. And I'm not actually alerting on these, which I'll talk about in a moment here, but that might be a first step. Maybe I want to ensure that in the future, if this does happen, I want to get that immediate notification. I want to be notified so that I can actually respond to it. So coming over here, I want to see, why is my model seeing such a drop in accuracy? Well, the first thing I might want to understand if I'm looking at this purely from getting notified from a performance perspective is, who's impacted? Are they equally impacted? And again, if I'm doing some kind of classification, if there's certain labels that were impacted more than others. So in that case, I segmented on the labels so I can use the tracing view to actually understand which segments or cohorts of predictions actually were impacted more than others. So again, I'm looking at that accuracy metric here. I'm looking at kind of a general aggregation over the time period that I'm looking at here. And I can see that, for instance, the for sale category actually had the most drop in accuracy, or the kind of the worst accuracy during that time period, versus the medical documents, the baseball documents. They're a little bit above the curve, and then I can kind of see where other things are relatively in line. But I can see that the for sale group here actually had the most predictions. So that's the light blue bar in the back. And then I can see that even though it had the most predictions, it had the lowest amount of accuracy. So I can do that on a number of different metrics here, right? If I wanted to understand precision, false positive rate, F1 score, to really understand how they all compare against each other. I can also do something like maybe I want to drill down into a particular point in time where I started to see that drop happen to understand how did this compare not just for the overall whole, but how did it compare for a particular point in time compared to the window that I'm looking at here. And so, like I said, drilling into particular segments or cohorts is incredibly powerful. I could do that on the performance page as well. So maybe I want to see how the baseball categories comparing to the other ones. Like I said, the accuracy tends to be pretty higher compared to the rest on that one, versus something like the for sale category actually seems to be pretty low, pretty representative of that drop that I'm seeing here. So the next question is what changed? So I can see, for instance, the outputs of my model, what's changed here. I can look at things like the overall drift in maybe the prediction, what are the categories that have suddenly shifted? And I can see here, for instance, the for sale category had that spike in the amount of predictions that it was ultimately resulting in. And then I can also see things like the inputs that fed in that ultimately created those predictions. So a couple ones that I'll highlight here. I mentioned that I was capturing information about the raw document as well as information about the tokens, as in addition to the actual embeddings that were being created. So first off, I can see that WhyLabs is tracking the drift distance here. And I have a monitor set up where I'm looking at that drift distance. And I can see that WhyLabs sees the biggest change kind of in these two features here. And we extract these features automatically using a resolver. So I can see that, for instance, in the frequent items, I saw a pretty dramatic change, and I'll drill into what that change is in just a moment here. I also see a change in the closest clusters of embeddings. So without having to stare at a UMAP or any kind of complex visualization, I could actually see that WhyLabs makes it really easy to understand my embeddings for a lot of different use cases here. Identifying closest clusters, identifying distances within clusters, automatically identifying centroids in my embeddings distribution. So a lot of different out-of-the-box things that we can do here to give you a ton of visibility. Like I said, the frequent items was an interesting one that I want to drill into a little bit more here. If I drill in and I go ahead and select this particular point, I can see some pretty interesting stuff. I want to really compare against this period of time kind of earlier on where I saw some pretty good performance compared to what I'm seeing today. And if I drill down into this particular feature, this frequent terms extracted from my tokenizer, I can actually see that right at the point where I saw that sudden drift, where I see that drop in performance, I can actually see that my documents changed from English to Spanish. So I can see that the frequent words changed. I can see that they're completely different in the latter profiles, and that was a pretty sudden shift. But you can imagine if there were certain categories that your model was expecting, if there was certain frequent strings that you were expecting before you pass it into maybe your tokenizer, you would want to be able to understand how those change over time, so you can drill in and see, for instance, what changed in between this particular time period or during this window. And then the logical question is, how did I get to the point where I have a monitor that I got notified of this problem? How do I ensure that if that performance drops again in the future, I'm notified so I can actually respond to it? And that's really where WhyLabs becomes incredibly important in not just looking at a point in time, like what happened during this particular point in time where we saw, this data set captured and profiled, during point A or point B, but really helping you understand how this happens over time. So for instance here, I really want to understand how I can create a monitor on that performance metric. We make it really easy. So I can come over here and say, I'm working with a classification model. I want to measure accuracy. Great. What do you want to measure, right? Maybe I have a static threshold that I want to ensure if it goes below this value, I want to get notified of it. Maybe I want to make it a little bit easier. And I really just care about looking at sudden changes or changes over time, maybe from a percentage basis. Or I could do both, right? You can have different monitors that are covering that, so you have full visibility into those changes. And then you also want to ensure that you're choosing the appropriate trailing window, right? Or baseline, excuse me. Because for instance, maybe you want to look at that trailing window for how the change happened over time, maybe over a few days, a month, a couple months, maybe a longer period than that. Or maybe you want to compare it to a particular range where your model was acting pretty normal. So, whether that was when you had a particular, model running, you were doing some A/B testing, and that during that time period, it pretty much operated exactly how you expected it to. You can say, great, that's my reference point, and I want to go ahead and compare it to that. Or I don't have it in this particular demo here, but we can also capture that training set like I was talking about. So when I'm looking at, how does my performance look like today? Well, I can compare that to maybe what it was trained on, so I can actually see how much change happened, in those accuracy metrics, in those different performance metrics for the type of model that you're working on, compared to a particular point in time, right? So lastly, I want to be able to define where I want to be notified of, or what kind of workflow I want to trigger if something goes wrong, right? Maybe I want to go ahead and trigger a Slack notification, trigger a PagerDuty notification. Maybe I want to go ahead and set up a webhook or an email. We make it really easy to tie into other systems. And again, if it's something like a webhook, maybe you want to trigger an automatic retraining. Maybe you want to trigger something in AWS like an SQS topic or an SQS queue or EventBridge or something like that, where you're going to take an action afterwards. And WhyLabs really just helps you to get the right notification to the right person at the right time. So we covered a few different topics. We talked about how WhyLabs can help us to look at performance, not just from a performance perspective, from understanding things like accuracy or comparing targets to any kind of ground truth, but also helping us to understand individual cohorts of my predictions or of my data set. Also being able to let me drill into particular profiles at particular times to understand, how does point A compare to point B? And then lastly, allowing me to easily set up monitors or, even more complex monitors if I have a very unique use case, where we can look at things like seasonality or complex trends and really help you to identify those changes in your data or in your predictions before they cause a problem and ultimately impact your customers. So coming back over, we talked about a few different things. Just to recap, 3 pillars of ML monitoring. When you think about what should a complete system look like, you need to be able to understand your inputs, you need to be able to understand your outputs, and you really need to have a system in place where you can create those performance metrics and understand the performance of your model. And so where do you go from here? I would highly recommend, we have some great examples on measuring performance on the doc site. You can get started with WhyLabs really easily. You can go to ylabs.ai/free, start off with an account, and If you want to know more, please reach out. I would also highly recommend joining our Slack community. And also, if you feel in a good mood today, please feel free to give us a star on our WhyLabs data logging library on GitHub. Thanks everyone for joining the stream. We'll go ahead and end the stream now.